So in this lesson, we're going to talk about zero and negative exponents. Okay, so first, zero exponents. Oops. Okay, so for zero exponents, any expression raised to the power of zero is equal to 1. Okay? Or in other words, a to the 0, or a is any number, is equal to 1. Okay, simple enough, just a definition of the zero exponent. Okay, a couple of examples in this box. Negative parentheses 3 to the 0. Well, 3 to the 0, that's 1. Okay, negative in front of it just makes the value -1. Okay, and the one below it, 8/9 to the 0. We have a fraction to the 0. It doesn't matter whether it's a fraction or whole number. Any expression raised to the power of 0 is always equal to 1. Okay? The only reason that the one above it was not positive when it was -1 is because you had that negative in front. All right. Negative exponents. Any expression raised to a negative exponent is equal to the reciprocal of that expression. Okay? Reciprocal just means when you flip a fraction, raised to the positive. Okay? So, a to the negative x, what that means, we flip it, is we turn it into a fraction. So think of like a to the negative x over 1. We flip it, we turn it upside down, but we make the exponent positive. Okay, 1 over a to the x. All right, so flip and make the exponent positive. Okay, so 10 to the -3 power is going to be 1 over 10 to the positive 3 power, which is going to, of course, be 1 over 1,000. Y to the -4 is going to be 1 over y to the positive 4. And nothing more to simplify there. Okay. So, if we look at some more examples, rewrite the following without an exponent. 7/2 in parentheses to the -2 power. Okay, so we know from our power of a product or power of a quotient rule that the exponent is going to distribute to both the 7 and the 2. So this is going to be 7 to the -2 power over 2 to the -2. Okay, and we know that when we have negative exponents, they're going to switch positions, that we're going to take reciprocals. So the 2 to the -2 is going to come to the top with a positive exponent, and the 7 to the second is going to come to the bottom also with a positive exponent. So that's going to be 2 squared over 7 squared, which we can clean up as 4 over 49. Okay, so -4 to the -2 is going to be 1 over -4 to the positive 2. Remember, only the exponent is going to become positive. So -4 squared is 16, so it's going to be 1 over 16. Okay, so number 3, we want to order the expressions by choosing less than, greater than, or equal to. Okay, so 4 to the -1 versus 4 to the -2. 4 to the -1 is 1/4. 4 to the -2 is 1 over 4 squared, or 1 over 16. Okay, and 1/4 is greater than 1/16. All right, so 1/4 to the -2, that's going to be 1 to the -2 over 4 to the -2. Which is going to be 4 to the positive 2 over 1 to the positive 2, which is 16 over 1, which is just 16. Okay, and 4 to the -2 is going to be 1 over 4 squared, which is 1 over 16. So we have 16 versus 1/16. That's going to get a greater than sign. All right, so the last one, 1/4 to the negative 2, which we know from the one above it is just 16. 1/4 to the negative 1, that's 1 to the negative 1 over 4 to the negative 1. We switch positions, that's going to be 4 to the positive 1 over 1 to the 1, which is 4 over 1, which is just 4. Okay, so that's going to get a greater than as well. Okay, number 4, rewrite the expression without a negative exponent. Simplify your answer as much as possible. Okay, so we have 4n to the negative 5. Okay, so what we can do, the negative exponent is only on the n, so this is 4 times 1 over n to the positive 5. So we have whole times fraction. I can put the whole over 1 and just multiply across, numerator, numerator, denominator, denominator. It's going to be 4 over n to the 5th. Okay, simplify u to the 4th times u to the negative 7. Okay, so we know from our product rule of exponents that when we have the same base u, we add the exponents. So that's going to be u to the 4 plus negative 7, which is going to be u to the negative 3. And we know by the definition of negative exponents, it's going to be the reciprocal of that with the positive exponent. That's going to be 1 over u cubed. Okay, number 6, x to the negative 5 over x squared. So we know from the quotient rule of exponents that when we have the same base, we subtract exponents with division. So that's going to be x to the negative 5 minus 2, which is x to the negative 7. And by our definition of negative exponents, that's 1 over x to the positive 7. Okay, number 7, a longer one. So we have the 5 and 10. We'll take those separately. I'm going to simplify both divisible by 5, so that's going to be 1 and a 2. So for the x's, you have x to the 5th, okay, in this division, and an x to the negative 9, so it's x to the 5 minus negative 9, so that's going to be x to the 14th, and that's going to go on top because it's a positive exponent. All right? Now for the y to the negative 7, that's going to come to the bottom as y to the positive 7. I'm going to cross that off the top. And for the z's, we have a z to the 8th divided by z to the negative 2. So that's going to be z to the 8 minus negative 2. So that's going to be z to the 10th. That's a positive exponent, so that's going to go in the numerator. Okay, so your answer is we have a 1 and an x to the 14th and a z to the 10th. So I'm going to write the numerator as just x to the 14th, z to the 10th. And our denominator is a y to the 7th, and we also have a 2 in front of it. Okay? That's your answer.